Welcome back to another one of my vector videos. This will be focusing on vector components, separating vectors up into their components. Okay, and this is the first video. There are two videos. This one is on 2D, the next one will be on 3D. So let's get to it. So I've already written this up, but basically you have our vector, and we can either use a squiggle or the arrow, whatever works for you. Remember, a component is like a component is defined as something, a part of something bigger. So like how piston is a component of a car engine, or things like that. Okay, and just like that, we have components and our vector. A vector is the letter we assigned with the squiggle to show that that's the vector, and this is what the vector is made up of. These are the components that make up this A vector. 3i plus 2j are the components that make up this A vector. And I've drawn it here. So we have going in the positive I direction and going in the positive j direction. 3i, we have 3i in the positive I direction, then we're adding 2j in the positive j direction. And that will in turn give us a vector. If you watch my vector addition video, this will basically, you should already really know this, how to do it, but you add 3i to 2j and you get the A vector. And we usually just write it like that, but if you're finding the components, you'd be finding this 3i 2j part. But if you're given something like this, you've already got the components. But I'll show you a little bit more as well. Okay, these are just different ways you'll come across the sort of things. So I don't know why I squiggled that out, but I'll show you that in a minute. Here we have R, which is our vector, and X would be going in the X direction and Y would be going in the Y direction. That's if you're used to using X's and Y's instead of I's and J's. These are just different ways you can see things. So when I explain them in future videos, you can understand fully. And here, I use this in statics. I've been taught this in statics, but this is just a different way I've seen it done, where you have capital R is your magnitude, or the force usually in statics, but when you're looking for the X component, you've got capital R and then a subscript X, which is just the same as this, just written differently. It just means this is the X component of R. And this is with the Y subscript, it means this is the Y component of R. Okay? So, also, I'll draw this again. If you have something like this, R, and you've got an angle, and you're trying to find the components, that will be this one and this one, and that'll be basically the same as this, Rx, Y. Sometimes it'll be, if you have a vector like that and you want to find the components of like this, you would just, it'll be the exact same thing. You just replace this with J, this with I, and this with the vector. I'll actually put the vectors notation there. And I'm not going to show you how to use the formulas, but if you came and you were looking for the certain formulas, Rx, this one here, subscript X, equals R cosine of theta. And R subscript Y equals R sine theta. Which it basically means, to find this, sine theta equals opposite over hypotenuse. So this is just rearranged, so you can find Ry from the angle and the magnitude. And same with Rx. Cosine is adjacent over hypotenuse. So that's how that works. Okay, I'll explain those a bit when I teach that video. But really that's all there is to need to know, breaking them up into their components. That is the vector and these are the components. That's the components, this is the vector, this is the vector, those are the components, this is the vector, those are the components. Okay, well I hope you learnt something from this video. Thanks for watching and have a good day.